Hey you guys, where we last left off, we were finishing up talking about constructors, whether they be parameterized or unparameterized or copy constructors, as well as talking about the destructor. And this isn't all that's related to classes, and in the previous two videos when I was establishing a context and talking about how structures don't have functions properly binded to it, well, in this video we're going to remedy that problem that I had. And this is going to be the introduction of methods as well as two special types of methods called setters and getters. But we'll get to them in more detail later. So one thing that's missing from here is a function that can print the contents of my data. A function that is properly binded to my class that I can call with my class. So the objective with this function that I want to call that's binded to my class, I just want to do something, well, like this. I want to do something like that. I just want to print e.print and have it all print out. So what I'm looking for is something called a method. And what's the difference between a function and a method? Well, a function is independent. It's independent from a structure, it's independent from a class, independent from anything. It's not binded to anything else. It's kind of like an independent variable. However, a method is a function that is specifically binded to a class. And how I can go about creating a method is that, well, it's as simple as declaring a function inside of a class. So here I go inside of the class's declaration and I can say void print. And I don't know, I can have something like this where I am printing out the value of x, then y, then y, z, then z. Something that you may have noticed is that here within the definition of the function, I access the private data inside of the class. And this is one of the benefits as well as one of the differences between a function and a method is that because the method is properly binded to the class, I can use the data structures and data members inside of the class, meaning the attributes, as kind of like global variables, right? In this case, x, y, and z with the underscores before them, they're kind of like global variables that are declared within the scope of this function. So by kind of like exploiting that feature, I guess, I'm able to have something that's, I guess, it's easier to do, right? When you create methods like this, you usually want to deal with the internal variables, and it's kind of easier to do so when it's part of the class because, you know, they don't have to be part of the function arguments and you know what they are, and it's like you don't need to be keeping track of like, oh, what's my input? You know, how if my input's different, how does that affect my function, right? I don't really have to worry about that here. So that makes things here a lot easier and simpler, to be honest. So why don't we go about not only calling print for Q, but for E as well. And let's see the results of this program. I keep forgetting that I need to compile with a more updated standard. But anyways, here we are. So one thing that I'd like to talk about is, and actually let's get the last few. Oh, hey, that's actually quite nice. So for those that don't know, tail gets the last 10 lines of a file, and I got really lucky because it all contained main. But let's look at the outputs here. So here I only call print for these two lines, right? And that's represented by these two lines here. However, I have some additional printing statements that are going on here. And I hope these are a little bit self-explicit on what's going on. But at this line, I'm actually printing this. Because in my unparameterized constructor, I print the string unparam constructor. And in my parameterized constructor, I print param constructor. As well as in my copy constructor, I print copy constructor. So these because I call three different types of constructors, here I'm printing the data for three different types of constructors. So then I go step through my program with these declarations with results in these three printings, and then I have these two function calls which results in these two lines being printed. And that's it. That's really all I do. After these two method calls to print, I return 0 and that's it. So because of this right here, I'm now the lifetime of Q, T, and E are over. So they need to be destroyed. And because they need to be destroyed, well, the way that we do that is by calling the destructor for the class. So in the destructor, I very cleverly added a print statement that printed destructors. So I know that all 3 of my constructors have been created. Some stuff happens, and then the destructor is called, and this is how I know it's called. And it's a very simple way to make a simple test to see if your constructors are being called properly, or if your destructor is being called properly and doing what it's supposed to do. Here, because we only have 3 statically typed variables, the computer itself will handle the destruction of those variables. But let's say, for example, I had a dynamically allocated class. Well, here in the destructor, I had to free all that memory that I allocated before. So now that we've talked about methods in a general sense, I'd like to talk to you guys about setters. So here, because I have these attributes as private variables, I cannot access them directly. So what does a setter let me to do? Well, a setter will let me, it's a controlled way of setting a different value to my private attributes here, right? So the setters kind of act like a filter against the user, so that way they don't do something, I guess, illegal for the class. For example, let's say the application of this point3d is being used in some code, and for some reason or another the values can't be negative, right? So at all costs, x, y, and z cannot be negative. They can be 0 or positive, but they cannot be negative. Well, I kind of run into a problem here, because the code that I have here, I will need to create a new class if I want a new pair of x, y, and z coordinates, and that's not memory efficient. So I will need to change. It does make sense to have these changeable. However, with that additional constraint that they can't be negative, I can't really trust my user to follow those rules. So the workaround for this is to create a setter method where I can set either all 3 of them or 2 of them, and I can create 3 different setters for each one of these attributes, and so that way we can set it to that specific, to a specific value, and we have a custom constraint that we want it greater than 0, and we can exercise and, I guess, enforce that constraint within the setter function. So why don't we see what that looks like? Simple enough, right? So this has a similar declaration as my print method does, but here I have this is still a method. It's just this serves, I guess, a specialized. We consider it a special method just because it has a special interaction right above other things. And here I have my set x, where I take an input, which is some arbitrary x. I check, okay, if it's greater than or equal to 0, then we're good. Otherwise, we do nothing. And what I do here is up to me. If I wanted to do something like that, that's okay. If I wanted to do something like else and say, maybe do some cout and tell the user, hey, wrong number, something like that, that's fine too. Right, I myself as the programmer have the tools and the discretion to handle this how I want to handle this. In these other ones, if it's less than 0, I do nothing, and in this one, in this set x specifically, I say, hey, wrong number, you gotta make it positive. And you can call other functions, you can call other methods, right? How you handle this error is up to you, right? But for this example, for keeping that simple, we're not going to do anything. So I essentially have, a setter for each attribute. And, so sometimes that's what you want to do. Sometimes you want to have a setter for an attribute, but not always. It's not always a good idea to have a setter for every attribute. But for variables that you can see that can be easily modified and maybe should be modified and should be easily modified, maybe with some constraints, you should definitely put a setter function for. And its simple objective is just to set the input value to the private data if it meets a criteria. And you can define that criteria. And there can be none. There can be no criteria. You can just let the user define whatever value they want to for the private data. And if that's really the case, just make it public. But for private data, you usually set it private for a reason. You don't want the user doing something foolish, and having a setter function will let the user change the value, but you get to be careful with that input. You get to say, hey, you can't do this, or you can't do that, or you can't do this other thing, and you get the power to do that. Lastly, I wanted to talk about getter functions. For simple variables, you typically make them for simple variables, just because getters, they just return the private data. So since I have 3 attributes, I'm going to have 3 getters. I'm going to have a getter for X, a getter for Y, and a getter for Z. And, the format's a little bit different, and you may want to make multiple copies of getters just because of how people look at getters. So here I have set X, set Y, and set Z. So why don't we take a look at the getters now. Here they are, not that bad, mostly one-liners. So here I just have X, Y, and Z. You don't always have to follow this. You can have get underscore X or get underscore Y, get underscore Z. There's a whole bunch of ways of doing getters. Some people will say we'll have something like that, or they'll put an underscore or a dash. This stuff is really up to you, how you want to define these getters. But I just like to say, okay, X, Y, and Z, just because it feels a little bit easier to use. But anyways, that's up to you. So one thing that makes this special method different than all the others that I've covered so far is the use of the const keyword here. And what the const keyword in this place does is that it transforms this whole body here, this body of code that I've highlighted. That block is now considered constant. It has const limitations. So within this const code block now, I can't edit underscore X. And this is what I want to do because I want this to be read only. When I have getters, I want it to be read only. Under no circumstances should underscore X change if I'm just getting the value, if I'm just reading the value. For me and myself here, I only want, underscore X, underscore Y, underscore Z to change if it's a setter. Otherwise, under all other circumstances, I want it to be const. And since I'm only dealing with the private data here, with the private attributes here, it's safe for me to put const. If I need to do some transformations and some other variables, well, I can't really put the const there because I'll be editing different variables in that code body. But for this, just because it's so simple, a simple getter, I just want to get the data. I don't want the data to be manipulated while I'm reading it, so I put the const there. And the same thing applies for when I do Y and when I do Z. And that wraps it up for about this video. So we know about methods. We have the problem solved that we can bind functions to classes or to a data structure properly, which is absolutely great. It makes using the user-defined variables much easier. Again, classes are user-defined variables. In the next video, we're going to take a look at a dynamically allocated example, just because it's a little bit spicier, and this is a relatively simple class compared to others that are possible, and I kind of want to introduce kind of a more complex example to kind of get you guys thinking about classes and seeing what they can look like. And I'll see you there.